In the present video, I will discuss the how to solve the linear programming problem by graphical method. Let's see the problem. Solve the following linear programming problem by graphical method. Minimize z equal to 20x1 plus 10x2 subject to x1 plus 2x2 less than or equal to 40, 3x1 plus x2 greater than or equal to 30, 4x1 plus 3x2 greater than or equal to 60, and x1 comma x2 greater than or equal to the 0. Here z equal to 20x1 plus 10x2 is the objective function, and x1 and x2 are the decision variables, and x1 plus 2x2 less than or equal to 40, 3x1 plus x2 greater than or equal to 30, and 4x1 plus 3x2 greater than or equal to 60 are the constraints, and x1 comma x2 greater than or equal to 0 is the non-negativity constraints. Let's see the solution. First step is consider each inequality constraint as an equation. For this, we have to replace the inequality symbol with equal symbol in the constraints. Then constraints becomes the x1 plus 2x2 equal to 40, 3x1 plus x2 equal to 30, 4x1 plus 3x2 equal to 60. Next step is each constraint will be plotted on the graph by treating it as linear equation. Before that, we have to find the coordinates of the each constraint equation. So let's see for the first constraint equation, that is x1 plus 2x2 equal to 40. First we have to consider the x1 value equal to 0 and substitute in the x1 plus 2x2 equal to 40 equation. Then x2 value is the 20. Similarly, consider x2 value is the 0 and substitute in the x1 plus 2x2 equal to 40 equation. Then x1 value is the 40. Then coordinates of this equation is 40, 20. Next we have to see the second constraint equation, that is 3x1 plus x2 equal to 30. Let consider x1 equal to 0 and substitute in the equation. Then we will get the x2 value is the 30. Similarly, consider the x2 value is the 0. Then x1 value will become the 10. Then coordinates are the 10, 30. Similarly, we have to see the coordinates for the third constraint equation, that is 4x1 plus 3x2 equal to 60. Let consider x1 equal to 0 and substitute in the equation. Then x2 value is the 20. Similarly, consider x2 value is the 0 and substitute in the equation. Then x1 equal to the 15. Then coordinates are the 15, 20. Then each constraint will be plotted on the graph by treating it as linear equation, and treat x1 as the horizontal axis and x2 as the vertical axis on the graph sheet. Next, locate the first equation coordinates on the graph, that is 40, 20. So mark the 40 at x1 axis and mark the 20 at x2 axis. Then we have to join these 2 points by the line. Next we have to locate the second equation coordinates, that is 10, 30. So mark the 10 at x1 axis and mark the 30 at x2 axis. Then we have to join these 2 points by the line. Similarly, next we have to locate the third constraint equation coordinates, that is 15, 20. So mark the 15 at x1 axis and 20 at x2 axis. Then you have to join these 2 points by the line. Next step is mark the feasible region based on the appropriate inequality conditions of the constraints. In the first constraint, inequality symbol is less than or equal to. So we have to consider the region below the line. So below this line we have to considering the solution of the first constraint. Similarly, second constraint having the inequality symbol is greater than or equal to symbol. So region we have to consider for this constraint is above the line. So this region we have to consider in the solution for the second constraint. Next we have to observe the inequality symbol in the third constraint equation, that is greater than or equal to. So we have to consider in the region above this line, and this region we have to consider in the solution for the third constraint. Next we have to mark the feasible region. What do you mean by feasible region? Means the area which is bounded by all the constraints lines including all the boundary points. So we have to consider the region which is common for the all the constraints. So here observe that one so this is the common area for the all the constraints. So this area we have to considering is the feasible region, and also have to mark the extreme points of this feasible region. That extreme corner points are the A, B, C, D, and its coordinates are for the point A coordinates are the 15, 0, point B coordinates are the 40, 0, point C coordinates are the 4, 18, and point D coordinates are the 6, 12. Next step is evaluate the objective function at each extreme point of the feasible region as shown in below. So in the table, first we have to locate all the extreme points and its coordinates values. So extreme point A coordinates values are the 15, 0. Another extreme point B coordinates are the 40, 0. Another extreme point coordinates are the 4, 18, and another extreme point, that is D, coordinates are the 6, 12. Next we have to substitute these values in the objective function. So let's consider first extreme point coordinates are the 15, 0, which means we have to substitute x1 equal to 15 and x2 equal to the 0. Substitute in the objective function, that is z equal to 20x1 plus 10x2. Then we will get the objective function value, that is z equal to 20 into 15 plus 10 into 0. This value is the 300. Similarly, we have to substitute the another extreme point coordinates values are the 40, 0 in the objective function, that is z equal to 20 into 40 plus 10 into 0, that is the 800. And next we have to substitute another extreme point coordinates values, that is 4, 18 in the objective function. Then objective function value is the 260. And finally you have to substitute the coordinates values of the another extreme point D point coordinates, that is 6, 12. Substitute 6, 12 in the objective function, that is 20 into 6 plus 10 into 12. So that is the 240. So among all the values, minimum value is the z equal to 240 at the extreme point of the 6, 12. So hence the optimal solution to the linear programming problem is x1 equal to 6 and x2 equal to 12 and minimum z equal to the 240. And this is the solution, and thank you.